I know there's hardly any time to make anything, Ryan. It drives me bananas, right? Sometimes if I get a few extra minutes, I'll go grill hot dogs, right? But today it's been hurting me. So, and raining yesterday. So my son's now gotten himself into eating a can of soup for lunch because he wanted a sandwich. But then my daughter and I walked out there because he has lunch at 12 and we're at 12:30, and there's like a can of soup all over the counter. So we've gotten to making lunch. It's not cleaning up after our messes. All right, so steps to integration. So we start with basic, okay? So basic, right? Then if that doesn't work, we're going to look for a U-substitution. And this is going to make more sense, what I put in the left-hand column, in a few minutes, okay? So then we look for a U-substitution problem. So you're looking for something that has an inner function, okay? A function inside of a function, just like the chain rule. So it looks like if it was a derivative, you'd take the chain rule on it, okay? Then we would look for arcs. And by that, I mean we're looking for inverse trig, which we're going to get to in this lesson because there's sometimes some chain rule embedded in it. We're not going to get to it today, but it comes. This is a really long lesson because there's a look at all those I can statements. We got to cover all of those in this one section, right? And then finally, you might need to simplify something. Sometimes I look for the simplify ones kind of when I'm doing the basic ones, okay? Because if I can simplify something, it might be easier than actually doing a chain rule or anything, okay? So the next part, again, you don't have a context for it yet. We're going to write it down so that when you're trying to do your homework later and you're too lazy to click on the YouTube video, or Mrs. Ballard doesn't post it, or you're too lazy to find your new one, you have some steps written out that maybe will jog your memory, okay, on what we did. So we are going to label the inside U. Okay, so your inner function is going to be the U. Then we are going to take the derivative of U and label du. Okay, again, it'll make more sense here in a few minutes. Match up the U and the du in the original problem. And remember, when we're creating something, when we're trying to match things up, we can only create numbers, not variables. Okay. Then you're going to integrate the new U equation. It says integrate new equation and put the equation for U back. Okay. I'll leave that on the left there for just a minute. All right, Jersey Mike's sounds good, doesn't it? That sounds like a good lunch. I miss my Friday lunches with the math department where I got Jersey Mike's. We haven't had that in a while at my house. Five Guys sounds pretty good too, doesn't it? I ate cottage cheese with fruit on it, so my lunch wasn't very exciting. And 4 Hershey Kisses. Yes, I agree. Jersey Mike's is better than Subway, but Subway is closer. But at least to me, it's closer. I don't live very far from school. All right, we're going to do this with polynomials first, okay? Although I don't think my children have ever tasted Subway, because if we're going to spend the money, we're going to drive to Jersey Mike's. So we're going to try this with polynomials first to make it easy, okay? Typically, we don't do this with polynomials. You'll see them more with radicals over it. You see this embedded into trig. You can see it embedded into logs and into e's, okay? But we're going to go easy with the polynomials. I think we kind of did the same thing with the chain rule when we started chain rules, to work in the context of the algebra we know and then bring it into some of the other things, okay? All right, so I am looking for an inside function. Can you guys help me in the chat? What is an inside function that you see in example 1? So tell me your inside function. Remember, you're helping me in the chat. That's part of our grade. So help me in the chat as part of the grade today. An inside, and I only want what's on the inside. All right. Nice work, everybody. Okay, so you guys have got, you're good at identifying this, and that makes U-substitution so much easier when we're good at identifying the inside function. So we're going to write that off to the side. I'm going to choose to write my U in orange, just like I wrote my chain rule U in orange. Okay. I'm going to introduce a new color though. I'm going to take the derivative of that right away. So this is part of it. Now all of a sudden we're putting that derivative in with the integral. So it's they go together. Okay. So I'm going to take the derivative of what I have. I'm going to write a little bit different notation than you've seen. So instead of writing u prime, okay, or instead of writing du dx, right? We did that for implicit. We're going to just write du. Okay, and then I'm going to take the derivative of x squared, which would be 2x. And then whenever I take a derivative of an x, I would write dx. And then derivative of 2 is just 2. Okay. All right. So now what I am looking for is, when I substitute in, I have to be in the same variable. So if I have x's in the equation, I want a dx at the end. If I have u's in the equation, I want a du at the end. Okay. I already know that when I set this up, that my u over here is equal to the x squared plus 2. We set it up that way. We wrote it that way on purpose. But then I can't use dx, right? I have to get rid of this 2x and this dx. And what do you know? When I took the derivative, I got lucky and both of those things were there. So I am allowed to substitute for 2x dx. I am allowed to put in du. Doesn't that look much nicer to integrate? We all could do that, right? Because all we have to do is add 1 and divide by the new exponent. So much nicer, right? So let's add 1. So I've got u to the third divided by my new exponent 3. Okay, what do I put at the end? What do I put at the end? Let's see what we remember if we've been doing our integration. What goes at the end? We're going to stay, for the most part today, in the indefinite world. So we would all have to put the plus c, and I think everybody capitalized it. Nice work, everybody. Nice work. Okay, so plus c. Now, the last thing said I have to take this u, and I have to plug it back in. So I would have the cubed over 3 plus c, and then we're going to plop that u back in, x squared plus 2. Done. We've now integrated it. Okay. We doing all right? Not too bad so far. Okay. All right. We're going to look at example 2. All right. I'm going to go, I think the u is this piece right here. Okay, so I'm looking for u. So u equals x cubed plus 2x minus 4. All right. I want to see what you do with this next piece. I'm going to give you that the left side is du. Please, in the chat, tell me what is the derivative of the right side. What would I want written out there? Here it comes. All right. I see Erica's answer. What else? What does everybody else think? I can see I said something wrong, but I like where we're going with it. Okay. So when I do the dx on the right, and it was my mistake in the way I said it, okay, we only need to write the dx one time, okay? And that's different, a little bit different than our implicit thinking, okay? So we do 3x plus 2 with a dx after it. And so you put it in parentheses, as if we would, technically what you did was distribute it in, right? But we don't want to see it, we want to see it in that factored form. Okay, so we're going to fix that on the next round. And the reason is, look at what I've got here. I only have one dx on the problem off to the left here, right? So I want to make sure that I can replace, and look, it's a straightforward replacement. So this is nice to substitute into. So for the orange there, for this orange chunk, I am getting to substitute in a u. And then for the blue, I have the 3x, I have the dx, so I can substitute in the du. Why isn't it 3x? It should be. Thank you. I wrote it wrong. Thank you, Tina, for catching my mistake. All right. So I'm going to integrate now. What do we have to do to the exponent to integrate? Can you guys tell me? What do I have to do to the 4 to integrate? All right, nice work. We are going to plus 1. Good. So we end up with u to the 5th over 5 plus c. And then we're going to substitute back in. It's going to be to the 5th power over 5 plus c. And we're going to put that u in, cubed plus 2x minus 4. All right, let's look at example 3. Remember, we are looking for an inside function. Okay, so you guys tell me in the chat, what's my inside function in example 3? What do you think's inside? Hello, Angel. Welcome to class. Thank you for the camera. I appreciate it. All right, good job. You guys are good at the inside functions. You are awesome. Okay. All right, so I know that that's my inside function. I'm going to look for my outside function now. So let's see, du equals derivative of 16 is 0. Derivative of negative x cubed is negative 3x squared with a dx after it. So there's a little bit more of a catch this time. So make sure you're paying attention. Okay. Do you see how we have the x squared? And I don't know why that dx is there. It should have been written, it should never be in the denominator. I don't know why it got thrown down there. I apologize about that. Bad typing on my part, I guess. Do you see how I have those parts that match, but I am missing the negative 3? Okay. So I have to, in order to substitute in the du piece, which I need because I can't leave the dx piece in there if I'm going to do U-substitution, I need a negative 3 in there. So there's 2 ways that we are allowed to change a function, okay? It's when we add 0 or when we multiply by 1. So the easiest way to do this is to multiply by 1. But the one we're going to multiply by is negative 3 over negative 3. So in order to introduce the negative 3 in the numerator with the x squared, okay, I also have to put a negative 3 in the denominator so it does not change my function in any way. Okay, I'm going to rewrite a little bit. So I'm going to rearrange this just a little bit. Okay, I am going to choose to take this negative 3 outside the integral symbol, but remember it's in a denominator. So I'm going to keep that 3 outside. Okay. I'm going to keep my numerator negative 3x squared, my dx. I'm going to still have my 16x minus or x cubed downstairs. But something looks a little bit off, doesn't it? I don't normally just have a 3 floating underneath a denominator anywhere, right? What do you think should go in that numerator? If there's nothing in the numerator, what do we assume is there? What do you guys think? Oh my gosh. Thank goodness. I like hold my breath every time we do something like that because you guys are apt to put 0. You guys are so smart. It should be 1. And you guys were quick on that one. That made my day. All right. We're ready to U-substitute, okay? When you move the negative 3 to the other side, you take, no, I don't. I missed the negative. Thank you, Marilyn. So keep the negative with it, okay? So you're right. I should have it there, okay? All right. It was a righto instead of a typo because I'm writing, right? It was my righto. All right. So we're negative 1/3. The integral, we're going to go ahead and get my U-substitution done here. So my U is going to get substituted in for the 16x cubed. The negative 3x squared dx, I get to substitute in du. And just like the outside of the integral symbol, the inside also has a 1 hanging out in the numerator. All right, I'm almost at where I can integrate that. But I know to integrate, I have to move this upstairs. So what do I need to do to move that upstairs? Can you guys tell me in the chat, how do I move the u squared upstairs? Getting some things in the chat. I'm waiting just a little bit because I want to give everybody a chance. Okay. I like how I'm seeing the word exponent and negative. I appreciate that Erica they just showed me. That's fine. Okay. The exponent's not going to become 1/2 because I don't have a radical, but Ivan, that's coming. Okay, so you're a little bit ahead of where we're at yet. Okay, if there's a radical over it, then we turn it into a fraction. Okay, so all we're going to simply do here is just make it negative. Okay, but Ivan, thank you for putting that in the chat, so it gave me a chance to bring it up. Okay. All right, we're going to do our little add 1 deal. So we've got -1/3 u to the -1 divided by -1, always plus c. Don't want to forget that. In the next unit that we do, we will actually get to a free response question pretty good. And one of the points on the free response questions that go with the Unit 7 stuff is on the 9 points of free response, one of them is actually plus c. So you have to get that down. Okay, even though I know the stuff we're doing is super basic right now, you have to have the plus c. Okay. All right, double negative goes positive. I am going to go ahead and bring that u down before I substitute back in. I'm just going to leave it as 1/3u plus c. And then we're going to substitute the u back in. So 1/3 times 16 minus x cubed plus c. I'll give you a few seconds there. Okay, let's take a look at 4. Because notice we built one little tiny thing onto that, right? We had to have the coefficients in front. All right, looking at example 4, what's the u? Tell me in the chat. What are we going to use for u? Oh, I went and ruined it, didn't I? What are we going to use for u? Okay, 4x minus 1. Good. All right, so that means then that du is simply 4dx. So look at what I have. I have the dx. What am I missing in my original that I need to add in? Can you tell me what am I missing in my original that I need to add in? What do you guys think? What am I missing in my original that I need to add in? Good job. Okay, and in order to introduce that, just like in the last one, I'm going to do a 4 in the numerator and a 4 in the denominator. Okay, because that means I'm multiplying by 1. All right, let's do a little rewriting. I'm going to take the denominator 4 and put it out front again. And then you guys told me I'm allowed to put a 1 in the numerator. And then we've got the square root. I've got this 4 hanging out. I've got the dx, and then inside the square root, I've got the 4x minus 1. So all I did was rewrite by taking my number out into the front of the integral. All right, let's actually do the U-substitution step now. So we've got the square root. I'm going to substitute u in for the 4x minus 1. And then for the 4dx, which I have here, I get to substitute in du. All right, before I integrate, I still have one more thing I've got to do. Okay, I need to rewrite the u to some power. So what power am I going to put on the u? Because I've got the radical over it, and I can't integrate it that way because I need to be able to add 1 to the exponent. What exponent do I get for the radical? Tell me in the chat. All right, there we go. 1/2 du. Perfect. Okay, we're going to go ahead and do our integration. We're adding our fancy 1, which is 2/2. So I get u to the 3/2. Oh, I should have left myself some space. Let me try that again. U to the 3/2. I divide by 3/2, or we've been taking the shortcut where we multiply by our reciprocal. Okay, what am I missing at the end? What do I need to put on there still? I need something else. I couldn't even trick any of you. You guys are so smart. Plus C. Perfect. All right, I'm going to do a little bit of simplifying. 2 goes into 4 twice, so I would get 1/6, and then my u, which is this 4x minus 1, gets subbed back in to the 3/2 plus c. Okay. Let's do it. We're going to do a couple more. All right, couple more. All right, let's take a look at example 5. So it looks like my u is probably what's inside that radical, right? U equals 2x squared plus 5. So du equals 4x dx. Nice, right? When we see something like that, we should be like jumping up and down for joy because we don't even have to add anything. And look it, we have everything we need. We saw that on the test and you would say, thank you, Mrs. Ballard, for making it easy. That's probably not what you're going to see on the test. Maybe I'll do one, but that won't be what moves. And the AP test probably won't be that nice. I don't know, we'll see. Stranger things have happened, right? Okay, so for the x squared plus 5, we're going to put in that u. For the 4x dx, we're going to put in a du. Okay, and again, I'm going to convert to that fractional exponent. All right, I'm going to add my fancy 1. So plus 2 over 2. So we've got the integral of not integral. We're taking the integral, Mrs. Ballard, don't write it. U to the 3/2. We're going to divide by 3/2, or what would my coefficient become out front? What's the other way I can write that? Instead of dividing by 3/2, tell me in the chat, what am I going to put out front? All right, good job. 2/3 and then plus C. And then we've got to substitute our U back in. So 2/3, 2x squared plus 5 to the 3/2 power plus C. All right. How are we doing? Are we doing okay? All right. Example 6, what's the U? Tell me in the chat. What are we going to use for U? Erica was quick. Nice job. Easy, right? But mathematicians are lazy. Notice we didn't put parentheses around that, right? We should have, right? You technically should have. But inside the trig is the 4x, which means that du is equal to 4dx. And what do you know? The 4 is missing, right? I have the dx, but I don't have the 4. So I'm going to add the 4 to the top and the bottom. I'm going to choose to rewrite it and pull that denominator 4 out front and put the 1 on top. And then we are left with 4. Where's my blue? Cosine of 4x in orange, and then dx in light blue there. Okay, we're ready for that u-sub step now. So I've got 1/4 the integral. I'm keeping the cosine. I am putting in u for the 4, and I'm putting in du for the 4dx, because that's what we got over here. All right, let's see if we remember this. We did it the other day. What is the integral of cosine? The integral of cosine. What do you guys think? Integral of cosine. Good job. It is in fact sine. So sine of u plus c. We're going to substitute our u back in. So sine of 4x plus c. Technically, we should put parentheses, but you know us lazy mathematicians, we're probably not going to. Okay, Let's do 7. Okay, a little bit different on 7. The U is a little bit more obvious. So our U is going to be 7x plus 5. Can you help me in the chat? What am I going to write for my du this time? What's going to be du? Very nice. I'm liking the dx's after that. Excellent work, everybody. All right. Oh, but I've got a problem, don't I? I've got to add that 7 to the top and the bottom again. So, and again, hopefully you've noticed the pattern. I end up taking the denominator 1 out front. The numerator 1 stays inside. Where's my purple? I used purple. Cosine, parentheses, and then it was my orange is the 7x plus 5. And guys, I'm writing a lot of steps today because I want to make sure you're seeing every little part. If it was me just doing this, I would probably skip that line and go straight to my U sub part. Okay. All right. 1/7. So 1/7, the integral of cosine, we're putting in our U. And then for the 7 dx, which matches over here, I get du. All right, 1/7. One more time. What's the integral of cosine? What's the integral of cosine? Ah, you didn't forget. Good. Sine. And then of u plus c. And then we get 1/7 sine. I'm going to substitute my u in 7x plus 5 plus c. All right, I've got a question for you. Who's tired of taking notes? Who is done with taking notes today? You know what? I think I'm done instructing notes today, okay? And I'm not going to give you, there's a little tiny bit of homework associated with this, but I'm not even going to give you a video to finish these yet, okay? No, Brody, it's not for the rest of the year, okay? But you know what? Our notes in this class finish a lot sooner than in my other classes, okay? But you know what? You know what I am in the mood for? I would like to play a game. Would anyone like to play a game? Angel says he's ready. Rebecca's ready. Marilyn's ready. Okay. What's our